In this lesson, we're going to look at factoring, which is the fun stuff. So, in the previous lessons, we have looked at the way we'd multiply brackets by other brackets. We looked at the way we multiply binomials together. In this case, we're going to do something that's very similar, but in the opposite direction. So we're actually going to go in a reverse direction. Instead of multiplying, we're going to try and take out the greatest common number or a letter from an equation, and then turn it into an expression that involves separating terms into two distinct, brackets. Let's take a look and see what I mean by that. We'll start with something simple and then we'll move on to something that's more complicated. So in this example, we have 3x plus 15. As you can see that the number 3 and 15, they're both divisible by the number 3. Which means we can take number 3 out, put brackets, and then insert an expression where if we were to multiply 3 by x and 3 by 5, this would be our answer. So you can see that we're actually working backwards now. In this case, we have a number and a letter that can also be extracted. It can be taken out. So the greatest number that we can take out is the number 5, because 5 and 10 are both divisible by 5. We can also take out x. It won't be x squared, but rather x, because you actually don't have x squared here. When you take out x, you can write an expression inside the brackets, but the way to write it is you have to kind of do a backwards check. You have to ask yourself, what would I multiply this by in order to get this expression? So 5x would have to be multiplied by x in order to get 5x squared. Also similarly, what do I need to multiply this by in order to get negative 10x? So in order to get a negative number, automatically we know that positive times negative will give us a negative. So now we've taken care of the sign. Now we need to take care of the number. 5 times what gives us 10? The answer is 2. And x times what gives us x? And the answer is 1. So we only have to multiply by 2. So 5x times negative 2 gives us negative 10x. Okay. Next example, we have a much longer expression. In this case, we can see that the number 4 is probably going to be our greatest common factor, because every single number here is divisible by 4. We cannot divide by x anymore because our final number only has a number. It does not have a letter. And so when we talk about the greatest common factor, we can only take out number 4. 4 times what gives us 4x squared? Well, the answer is x squared. 4 times what? What would you multiply 4 by in order to get 16x? 4 times 4 gives us 16. So it'd be 4. And you have to have an x present as well. So 4 times 4x will give us 16x. 4 multiplied by what number will give us 24, and the number would be the number 6. So we write the number 6, and we can close the bracket. Okay, we cannot factor it further. This is a little bit different because we have a lot of negatives. So we have a negative here, we have a negative there, and we have a lot of zeros. So the question is, what's our greatest common factor? Automatically we look at the letters and we can see that the last number does not have a letter, and so we cannot factor out an x. But we do have those numbers that have lots of zeros, so whenever there's a 0 present, automatically we think about the possibility of dividing that number by 10. In this case, it's kind of nice to get rid of that negative also. So when we factor a number out, it's also nice to take the negative with it. In this case, we're going to take negative 10 out because every number that's present is divisible by the number 10. Okay, negative 10, we do backwards thinking again. Negative 10 multiplied by what gives us negative 10x squared, and the answer is x squared. It has to be positive inside the bracket because, again, negative times a positive gives us a negative answer. Negative times negative will give us a positive answer. Negative 10 times 2, in this case there's an x present, so we're going to leave an x with it, gives us positive 20x. And negative 10 times a positive, so negative times positive gives us negative. And it's a 3 to give us the answer of 30. Okay, can this be further factored any further? And the answer is no. Okay, so in this case we're going to try and apply what we've learned. And we have an example where we have dimensions of, we're trying to find dimensions of a rectangle with this given area. Sometimes you look at math and you ask yourself, well, why would I ever have an area expressed in this form? And I don't know what the answer is, but we do have to try to figure out what the dimensions are. And we can do that by factoring. We know that the area of a rectangle, our favorite rectangle, dimensions are length by width, and so the question is what's our length and what's our width? We're going to factor this. Okay, so we're going to take 21, x squared, and 3x, and we'll find out that the greatest common factor is the number 3 for the numbers. But we can also take out the letter x. So we're going to write 3x times 7x plus, the question is, what's our last answer? So how did I get 7x? Well, 3x times what gives us 21? So 3 times 7 gives us 21. And x times x would give us x squared. The question is, what do we put here in order to get 3x? And the answer is 1. Anything times 1 is that number. So 3x times 1 would give us 3x. Okay, so this is the expression that we have in a factored form, which means 3x will probably be its width, and 7x plus 1 will be its length. And it's not over. We have to keep in mind that if x is actually given a value of 1 meter, the question is what would be the length and width of this rectangle. So we'll plug in the numbers. For width, we're going to say 7 times 1, because the sign between 7 and x is multiplication. So 7 times 1 plus 1 will give us 7 plus 1, which is 8. So this is our length. For our width, it's simply 3 times x, and 3 times x is 3 times 1, and the answer is 3. Okay, so in this case our width is 8 meters, and our length is 8 meters, and our width is 3 meters.